Hey, it's Mr. Lum again, and today we're going to be talking about pKw. Or in other words, we're going to be taking a look at the pH scale and the pH scale and how we derived one of those formulas of converting from pH to pOH. So earlier on we learned about Kw, and we learned that it's the water constant and how Kw equals 1.00 times 10 to the minus 14 at a temperature of 25 degrees Celsius. Okay, so we also learned that Kw equals the concentration of H3O plus times the concentration of OH minus. This comes from, well, it comes from this formula right here of 2H2O plus some energy, okay, and that makes H3O plus and OH minus. Now this is aqueous, okay, so this is AQ and this is AQ, okay, and this is, well, this should be H2O, this is liquid. Okay, so if we were to take a KQ equation or expression, or in other words a Kw expression, it would be products over reactants. But since the reactants are a liquid, it's just products times each other. So in other words, Kw equals H3O plus times OH minus, and that's how we get this formula right here. Now, let's take a look at what happens if, or how we derived one of those pH formulas. So if we were to take this and put this on a logarithmic scale, or in other words, take everything here and take the negative log of stuff, so the negative log of Kw and that would equal, well, the negative log of H3O and the negative log of OH. Okay, now we know a lot of these numbers here, like Kw is 1.00 times 10 to the minus 14, and if you take the negative log of this number right here, the negative log of that would be just 14. Okay, and the negative log of H3O plus, well, that's just our, remember this formula? pH equals the negative log of H3O plus. Okay, so that, all this is pH. Okay, and the negative log of OH minus, well, that's pOH equals the negative log of OH minus, okay, or in other words, plus pOH. Okay, so at 25 degrees, remember, the only thing that can change Kw is temperature. At 25 degrees, it's just 14 equals pH plus pOH. And that's how we got one of those formulas that we learned last time. Now, let's look at what happens at different temperatures. Okay, so I wrote some few questions out here, so hopefully you've had a chance to look at these, and if you want you can put the video on pause and try to answer them yourselves, but we're going to go ahead. So what happens to the pH of water when temperature increases? Well, so we're going to remember Le Chatelier's principles. If the temperature increases right here, so if the temperature increases, which way is this going to shift? Okay, well, it's going to figure that increases, it's going to shift right, shift towards the products. And what happens to the pH? Well, the concentration of H3O plus increases. Remember? And if you remember this, if the concentration of this increases, what means something that is, and this is the definition really of an acid, what happens to the pH of that acid if this increases? Well, you remember the pH starts to decrease. Remember, a pH of 1 is 10 times more acidic than a pH of 2. Okay, so let's write that down. So if the concentration of H3O plus increases, therefore the pH decreases. Okay, so a little bit opposite, but that's the way logarithms work. Okay, what happens to the pOH of water when temperatures increase? Again, if this increases, the concentration of OH increases. Therefore, pOH also decreases, because we're plugging into, if this number is bigger, then this number is going to be smaller. So this number decreases. Okay. So, in other words, if this number, when the temperature increases, if this number is becoming, like the concentration of this is becoming bigger and bigger, and this is becoming bigger and bigger as well, the pH is becoming smaller and smaller, and the pOH becomes smaller and smaller. So what happens to pKW? Okay? Or in other words, what happens to this over here? Because this is only works, it's only 14 at 25 degrees Celsius, but normally if it's not at, then we have to come up with a new formula which equals pKW equals pH plus pOH. Okay? And if this number is decreasing and this number is decreasing, then pKW must be decreasing. So let's write that into our notes. So if pH is decreasing and pOH is also decreasing, therefore, well, using this formula, pKW equals pH plus pOH, therefore pKW decreases. Okay, so when the temperature is increasing, pKW is going to be decreasing. And you can start to think about if the temperature is decreasing, what it can be, and yeah. So there'll always be like 1 or 2 questions on your final exam that'll be about pKW and the effects of temperature on that system. Okay? Next time.